As we discussed about the types of polymerization we completed. Okay, so we are discussing classification of plastics is over, ma? Completed?
No, ma'am.
No, okay. So classification of plastics, there are two types of plastics, ma? Thermoplastic resins and thermosetting resins. Okay, so thermoplastic resins, these are when we take thermoplastic resins, it will become soft on heating, soft on heating and hard on cooling. It will become soft on heating and hard on cooling because so you can see here thermoplastic polymer. You can see here the picture here diagram. So there are weak bonds are there between polymer chain. So the polymer is here it is formed with the weak bonds. Okay, polymer it is having weak bonds. So due to the presence of these weak bonds, when we are heating this polymer, okay, so it will become soft. Okay, it can be softened by heating and hardened on cooling. Okay, and again when you are cooling, again reappearing of this weak bonds will be taking place between polymer chains, and we get a hard product. Will get hard polymer. Okay, so thermoplastic resins are those which can be softened by heating and hardened on cooling. Okay, so due to the action of heat, the intermolecular forces between the polymer chains breaks. The intermolecular forces between the polymer chains breaks and facilitate easy movement of polymer chains. You can see here when we are applying the heat, so there is a breakage, breaking of chains will be taking place here. Okay, so due to this breaking of chains, okay, between the polymer chains, now we can shape into, we can mold into any shape. Okay, so and it facilitates the easy movement of polymer chain, facilitate the easy movement of polymer chain, which makes them softened, Here you can see no links between polymer chains, so it helps in free movement of polymer chain, and we can we'll get a soft material here. So by taking that soft material, we can mold into any shape. So thermoplastic resins, they will have a weak bonds. Okay, easily it will break. Okay, and the material becomes soft. And after becoming soft, we can mold into any shape. For example, a bottle. Okay, or any cups. Okay, so we are making into any shape, and after making into shape means when we cool it, again it will become hardened. Reappearing of bonds will be taking place. So that is the covalent bonds. Reappearing of bonds will be taking place. Okay, na? So that is about thermoplastic resins. On cooling the plastics, the intermolecular forces reappear, holding the polymer chain in fixed position. Holding the polymer chain. Again, we get this. Okay, holding the polymer chain in fixed position, which makes them rigid and hard. So generally, these thermoplastic resins, these are prepared by addition polymerization. Example: polyethylene, polyvinyl chloride, polystyrene, polytetrafluoroethylene, or Teflon. So 4 examples I gave here, thermoplastic resins. So thermoplastic resins are, okay, so these can be softened by heating and hardened on cooling. Why this material is becoming soft on heating means because of the presence of weak bonds between the polymer chains. So the bonds will break very easily, and there facilitates the easy movement of polymer chain. Okay, we'll get a soft material and we can make into any desired shape. Okay, so example will be, just a minute. Okay, my examples are polyethylene, polyvinyl chloride, polystyrene, polytetrafluoroethylene, or Teflon. So in this, we are going to discuss, we will take polyvinyl chloride and Teflon. We are going to discuss about polyvinyl chloride and Teflon in further classes. Now, thermosetting resins, the other type of resin, thermosetting resin. So thermosetting resins are resins which during molding process, Okay, when we are molding, when we are making any article during molding itself, so we get a hard material, it get hardened and later on cannot be softened by heating. Later on cannot be softened by heating. For example, you are taking this bottle, okay, so this bottle, after using that bottle, you can apply the heat, you will get a soft material. Okay, you can make into any other shape. But here thermosetting resins, these are the resins which during molding process, okay, get hardened. Means during molding process itself you will get a hard material, okay, and later on cannot be softened by heating. After that, if you are applying heat to that material, okay, that article, that material, it is not becoming soft. We are not getting soft material. Okay, why? Means these thermosetting resins, it will have a strong covalent bonds. Okay, so we'll get a three-dimensional cross-linked structures in thermosetting resins, so which are made up of strong covalent bonds. These strong covalent bonds, it maintains strength of the polymer. It maintains the strength of the polymer even under high temperature. If you are applying high temperature also, so this it will maintain the strength. Means why it is having more strength? Because so these resins, they are having strong covalent bonds. Okay, so thermosetting resins possess three-dimensional cross-linked structure, okay, made up of covalent bonds. These chains made of covalent bonds. Okay, so these strong covalent bonds maintain the strength of the polymer even under high temperature. So we can take the example, students, here bakelite. See, so we are having in our homes switchboard, switches, you can see the buttons here. Okay, these are made up of bakelite. Okay, so the switches you can take and you apply the heat, you won't get a soft material. Okay, it does not melt or you won't get a soft material because so the bakelite, it is thermosetting resin. The bakelite, it is having a strong covalent bond, a very hard material. If you're applying the heat also, it does not change, it remains as it is because these are having strong covalent bond, so they are having more strength. Okay, na? So this is about thermosetting resin. Okay, so one more diagram I am giving you. Thermoplastic resins, when you are applying the heat, there won't be any links, no links between polymer chains, helps in free movement, and you can go into any other shape. You can reshape. Okay, na? You can get a desired product. But here in thermosetting resins, you see links between polymer chain stops movement between them. This is thermosetting plastics, because they are having a these polymer chains are having a strong covalent bond. Okay, so when we are applying the heat, there won't be any change in this type of plastics, it remains as it is. Okay, so this is about thermoplastic resins and thermosetting resins. So these thermosetting resins, these are prepared by condensation polymerization. These are prepared by condensation polymerization. Okay, you know what is condensation polymerization. So we are taking two different monomers, two different molecules with functional groups, and here elimination of byproduct is taking place. Elimination of the small molecules like water, H2O, and methanol, etc. Okay, so this bakelite, okay, example of thermosetting resin. So this bakelite is prepared by condensation polymerization. Condensation polymerization. You can take nylon 66 also as example of thermosetting resin. So see the students, I gave some examples here, thermoplastic resins, thermosetting resins. Okay, so the first difference we can see, thermoplastic resins are formed. These are formed by addition polymerization. These are formed by addition polymerization, and thermosetting plastics are formed by condensation polymerization. Thermosetting plastics are formed by condensation polymerization. Thermoplastics by addition, thermosetting plastics by, these are formed by condensation polymerization. Students, hello? Students, are you there?
Yes, ma'am.
Yes, ma'am.
What is addition polymerization? Tell me. We completed, no? We are discussing difference between thermoplastic resins and thermosetting resins. What is addition polymerization? Take one example and tell me.
Ma'am, polyvinyl chloride, ma'am.
Polyvinyl chloride example. Okay. Tell me. What is addition polymerization? Here, first point is thermoplastic resins are formed by addition polymerization. Means what? What is mean by addition polymerization?
Ma'am, single monomer is taken and it is converted into
Okay,
polymer.
we are taking a single type of monomers.
Yes, ma'am.
A single type of monomers we are taking, and we are
Converting into polymer.
We are converting into polymer. Okay, by applying
Heat, pressure, and catalyst.
So when we are adding this same type of monomers together, adding together, how you are getting the polymer? Second point you see. Polymer, how you are getting? What type of polymer you can observe?
Long chains, ma'am.
Long chain linear polymers.
Yes,
chain
ma'am.
linear polymers. Yesterday you have seen, no?
Yes, ma'am.
Yes or no? Long chain linear polymers are formed with the chains are formed with weak bonds.
Weak van der Waals forces.
Weak van der Waals forces. Okay, ma? Now tell me, what is condensation polymerization? This is different. We prepared nylon 66. Tell me now. Condensation polymerization.
Ma'am, two monomers are taken and found as polymer with the breakdown of
taking two different molecules they are taking, but that monomer the monomer should have
byproduct.
Functional group.
Functional group, ma'am.
The monomer should have functional groups like OH,
HCl,
OH,
CO.
HCl, OH, COOH, NH2. 3 you remember?
Yes,
or
ma'am.
At least 2.
Carboxylic acid and NH2.
COOH and
NH2.
Okay. So what is condensation polymerization? Tell me. How polymer is formed here? How polymer is formed, ma, by condensation polymerization? See, we prepared nylon 66, yes or no?
Yes, ma'am.
How we prepared?
By removing the byproducts.
By removing the byproduct. What is the byproduct you got in nylon 66?
H2O, ma'am.
H2O. Okay.
HCl.
What are the HCl? We didn't get. What we got byproduct?
H2O, ma'am. Water.
H2O. Okay. What are the monomers you have taken in nylon 66?
Adipic
Adipic acid and hexamethylene.
Hexamethylene.
diamine.
Hexamethylene diamine. Okay. Adipic acid, hexamethylene diamine. Okay. So these two we have condensed these two monomers having functional group COOH, NH2, and elimination of byproduct H2O is taking place, and we got the nylon 66. So what is the structure we get, students, here?
3D network structure, ma'am.
Thermosetting resins will have
3D network structure.
3D network structure, 3-dimensional network structure with
strong covalent bonds.
So thermosetting plastics will have cross-linked structure constructed with the strong covalent bonds. So this is the second point. So first point is thermoplastic resins are formed by addition polymerization. Thermosetting plastics are formed by condensation polymerization. And second point is thermoplastic resins contain long chain linear polymers and held together by weak van der Waals forces, weak bonds. And thermosetting plastics contains 3-dimensional network structure constructed with a strong covalent bonds. Okay. Now, students, what is the third difference? We'll see. What is the third difference, ma? We discussed already. Thermoplastic resins become students
soft on heating and
hard on cooling. Soft on heating, hard on
cooling.
Why it is becoming soft, ma? Why it is becoming soft material when we are heating? Why the material becomes soft ma when we are heating?
Because it can be remolded.
It can be remolded. Okay, tell me why it is becoming soft.
It can be
Weak van
movement.
der Waals forces.
Weak van der Waals forces.
We can easily, due to the weak van der Waals forces, we can break easily that weak bonds, and we can get a soft material, and we can go for remolding process or reshaping. Okay, after reshaping again, when we are cooling that, we will get a hard product. Yes or no?
Yes, ma'am.
Okay, ma. Now tell me, thermosetting plastics, what happens when you are applying heat?
Does not become soft, ma'am.
Does not become soft on heating. Material remains as it is. Why it is not becoming soft, ma, when you are
Strong
applying?
covalent bond, ma'am.
Covalent bond. Okay. Now, which material is expensive in both thermoplastic resins or thermosetting resins?
Thermoplastic, ma'am.
Thermoplastics are expensive, okay, compared to the thermosetting. Thermosetting, they are cheap, okay. And thermoplastic resins are easily soluble in organic solvent. They have more soluble nature. The easily soluble in organic solvents. Thermosetting plastics are insoluble in organic solvents, okay. And these they are usually soft, weak, and less brittle in nature. Soft, weak, and less brittle in nature. So they are thermoplastic resins are soft, but they are weak. Okay, and they're not having more strength like thermosetting resins. No, weak and less brittle. Okay, brittle means easily breakable. But this type of plastics, thermoplastics, they have less brittle in nature. Means they won't break easily. Okay, whereas thermosetting resins, they are usually hard. They are usually hard, strong, and more brittle in nature. So they are hard materials, hard, strong, and more brittle. Okay, they have some brittleness, more brittle in nature. Okay, so this can be remolded, and thermosetting resins cannot be remolded. Okay, we cannot go for remolding. And example of thermoplastic polyethylene. మాట్లాడేది Premchand. Premchand. Okay, example of thermoplastic resin is polyethylene, whereas thermosetting plastic is bakelite. You can write bakelite, nylon 66, etc. Okay, students, we repeat again some differences, then we can go to the other topic. Okay, so what is the first difference, thermoplastic resin, thermosetting resin? Tell me fast. You will get the question this only, difference between thermoplastic resin, thermosetting resin. Tell me first point. Students? Hello?
Ma'am, they are formed by addition polymerization.
Which are formed?
Thermoplastic, ma'am.
Thermoplastics. Thermosetting?
Condensation polymerization.
Second point? Thermoplastic resins, second point?
It contains long chain linear polymers.
And held together by?
Weak van der Waals forces.
Van der Waals forces. Okay, next, thermosetting resins?
It contains 3D network structure with strong covalent bonds.
Strong covalent bonds. Okay, thermoplastic resins, third difference, tell me.
Become soft on heating and hard on cooling.
Next, thermosetting resins?
Does not become soft, ma'am, on heating.
Okay, fourth point, thermoplastic resin.
They are expensive.
Not
cheap.
Expensive. Okay. Next, fifth point.
They are soluble, ma'am, in organic solvents.
Organic solvents. Okay, like benzene, ether, and all, they are soluble. Now, thermosetting resins?
They are insoluble, ma'am.
Insoluble in organic solvents.
Solvents.
Okay. Okay. Now, next, thermoplastic resins are usually
soft, weak, and brittle in nature. Less brittle in nature.
Less brittle in nature. Whereas thermosetting resins?
They are more brittle in nature, hard and strong.
Hard and strong polymers. Now, thermoplastic resins can be
remolded, ma'am.
Remolded. Thermosetting resins cannot be
remolded.
Cannot be remolded. Now, example you tell me, thermoplastic resins examples.
Polyethylene. Polyethylene.
Any more?
Polyvinyl chloride, ma'am.
Polyvinyl chloride. Okay. Now here thermosetting resins, examples.
Bakelite,
Bakelite?
Nylon
Yes.
6,6.
Nylon 6,6. Okay, nylon 6,6. Okay. Students, you understood ma difference between thermoplastic resins, thermosetting resins?
Yes, ma'am.
We'll go to another topic now. Hello? This is simple topic ma. Difference between thermoplastic resin, thermosetting resin, you have to remember. What are the differences? Students. Hello?
Yes, ma'am.
We'll go to the other topic.
Yes, ma'am.
Now students write down ma. Next topic is compounding of plastics. Write down ma. Compounding of plastics. Hello? Are you there, students?
Yes, ma'am.
On your video, everybody. On your video. Students, on your video. All the students on your video, write down the topic. Compounding of plastics. You wrote, ma?
Yes, ma'am.
Okay, ma. Listen now. I think everybody knows the difference between thermoplastic resins and thermosetting resins. Okay, na? Now, next topic is compounding of plastics, ma. See the students, some polymers like polystyrene and polymethyl methacrylate. Okay. So they can be molded without application of additives, without using any ingredients, without using any ingredients. But many of the plastics like a phenolic or amino resins and cellulose resins, they require additives for molding into proper forms. Molding into proper forms. Okay. So I will tell you students now. We are preparing polyethylene, polyvinyl chloride. Okay. And polystyrene. So these are called resins. Polymer product resin. Okay. Polyethylene, polyvinyl chloride, polystyrene, whatever you are preparing. Okay, whatever the polymers you got during polymerization process. Okay, so that are called resins. So to this resins, to this polymer resins, we, for example, you are taking one container. Okay, in that first you will take polymer, polyvinyl chloride you are taking. Okay, I will show you now. I will tell you. See, this is polyethylene resin, polyvinyl chloride. You prepared now. Clear, students? You prepared polyvinyl chloride. Looking everybody white powder like you can see. Polyvinyl chloride you prepared. Now take one container. Take one container. In that you take first polyvinyl chloride. Okay, na? So you want to make one pipe or you want to make any raincoat like with polyvinyl chloride. First what you will do, you will take polyvinyl chloride in one container like. Okay. So after that what you do, you will add some chemicals. You will add some ingredients, some additives. Why we will add along with polymer resin, polyvinyl chloride in the container, you are going to add ingredients and you will mix everything. Okay, mixture of polymers, polymer product along with the ingredients. Okay, so here you are mixing to resin some other ingredients to improve or to increase the physical properties of the molded products. Physical properties of the molded products. Okay. For example, we are taking a polyvinyl chloride. So to this polyvinyl chloride, we will add one ingredient, plasticizers. Okay, you have taken a resin is PVC, polyvinyl chloride. Okay, you prepared polyvinyl chloride and that resin you have taken now in one container, polyvinyl chloride powder. So to that you will add plasticizers. So this is one ingredient. Why we are using this ingredient means to increase the plasticity and flexibility of the polymer resin, polyvinyl chloride. So to improve the properties of the plastics, to improve the properties of the polymer resins, we are going to add additives. We are going to add ingredients. We are going to add ingredients to get a good finishing products. To get a good finishing products, okay. So to improve the properties of that molded products, we will add chemical admixes, or we will call it as ingredients, or we will call it as additives. So if you are adding to that resin, polymer resin, other ingredients, and after adding, you will mix properly, and you will get like one material that you will go and mold into any article. You will go and mold into any article. Okay. So that is called, first we have to prepare the material. Okay, ma, that is called compounding of plastics. So compounding of plastics is the process of, listen carefully. Compounding of plastics is the process of adding ingredients to the polymer resin. Ingredients to the polymer resin, to the resin I will write, to the resin, which increases the physical properties of the molded products. Physical properties of the molded products. So what are the ingredients we are adding here is, I will tell you. Okay, ma. So we will use these ingredients, ma. In compounding of plastics, we will use these ingredients along with resin. So the following are the important additives, important ingredients added to the polymer resin. Okay. So why we are adding these ingredients means to increase the physical properties of the product, physical properties of the molded products. Okay. So what are the different ingredients we will add along with resin is, okay. So plasticizers we will add, fillers, stabilizers, lubricants, catalyst, coloring materials. All these are ingredients. All these are ingredients we are adding to the polymer. What we prepared polymer resin, we are adding to the polymer product. Okay. So this is called compounding of plastics. So one by one we have to discuss. Okay. So for each ingredient, why we are taking, what is the function, and example. Why we are using plasticizers, what is its function, and example. Okay, why we are adding these ingredients to the resin, that we are going to discuss. Now students, tell me what is compounding of plastics. First, what you will take? What you are taking, students, first? Hello? What you will take first, ma?
Resin, PVC.
Resin you will take, okay? Polymer. After preparing by polymerization process, you will get polymers, no? Like polyethylene, polyvinyl chloride, Teflon, bakelite. First you will take the resin. How many types are there, ma, resin?
3, ma'am.
3, yeah. How many types are there? How many types are there, resins? How many types? 2 types, ma, resins.
2 types, ma'am.
Thermoplastic resins,
Thermosetting.
thermosetting resins. Only 2 are there. Thermoplastic resins, thermosetting resins. Ma. Only 2 types are there, resins. Now tell me, what is compounding of plastics? To the resin, what we are going to add, ma?
Additives, ma'am.
Additives. Okay, additives. We are going to add additives, or we can write ingredients. Okay. So to the polymer resin, we are going to add ingredients. So that is called compounding of plastics. Why we are adding ingredients to the polymer resins, ma? Students?
To increase the physical properties, ma'am.
To increase the physical properties, of the molded products. For example, you want to get a hard material. Okay, you will add fillers. To improve the hardness of the plastics, you will add fillers. Okay, so to improve the physical properties of the molded products, we are going to add to polymer resin. Either you can take thermoplastic resin or thermosetting resin. So resins are two types, ma. Thermoplastic resin and thermosetting resin. Okay, whatever the resin you are selecting, in that you are going to add ingredients to improve the physical properties of the molded products, like a hardness, or to increase softness of the material. We will add plasticizers. Okay, to improve the plasticity, we will add plasticizers. Okay, so this is compulsory, ma. We go for compounding the plastics. After mixing everything to this resin, you are adding all this. You mix properly. Okay, then you can mold into any shape. Okay, so compounding of plastics is the process of adding chemical admixes, ingredients, that is ingredients to the resin, which increases the physical properties of the molded products. Hello, students.
Yes, ma'am.
Oh, okay, you understood, ma? Compounding of plastics.
Yes, ma'am.
Yes,
Okay.
ma'am.
Okay, now we will look into the ingredients, ma, what we are going to add to the resin. Okay, so to this resin, for example, thermoplastic resin, you will take polyethylene or polyvinyl chloride, that is thermoplastic resin. To that resin material, what you are going to add in that plasticizers, you will add fillers, stabilizers, lubricants, catalyst, and coloring materials. Okay, so we will discuss each function, why we are adding in polymer resins and going for molding process. So we will discuss each function and example. Okay, each ingredient, function, and example. So first one, resin. So resin we are taking, it is the binder or polymer material, which constitute the major portion of the plastic. Okay, means we are taking like you will add like 90% resin you will take, and 10% other ingredients you will add. Okay, then you can go for molding article. Okay, so major portion of the plastic what we will take is resin. So already we discussed, there are two kinds of resins. One is thermoplastic resin, the other one is thermosetting resin. So one form of resin, that is thermoplastic resin, is remoldable. We discussed, okay, remoldable, that is fusible and remoldable. We can go for reshape. Okay, it becomes soft on heating, hard on cooling. So that is the thermoplastic resin. Whereas the other form of resin is thermosetting resin. So these are non-fusible forms, and they have cross-linked structure with a strong covalent bonds. Okay, so this require catalyst. Okay, we will add catalyst in thermosetting resins. Okay, during molding process. Students, I gave examples here. Okay, I have taken thermoplastic resin. Okay, polyethylene resin, polyvinyl chloride resin. So to this powder, to this polyvinyl chloride, you take this in one container and add plasticizer. Okay, plasticizers will take chemical. Okay, for example, tricrysyl phosphate you have to add in that powder. Okay, after adding fillers you have to add. Okay, in that container you add some powder like a barium sulfate, you will add that chemical. After adding that, you will add stabilizers. You have to add stabilizers also. I gave stabilizers. For example, you add lead chromate. Okay, so after adding that, what else? Lubricants, oil you have to add. Okay, oil. Next, after adding oil, add catalyst. Catalyst, what we will add? Catalyst, for example, I give two here: hydrogen peroxide, zinc oxide. Any one you can add. Okay, in that mixture. We are mixing everything, students, in container first. Then we can go for molding article. Then last you have to add color. Okay, color, for example, you add lead chromate, yellow color, you will get the desired product. Otherwise, blue color, you add iron ferrocyanide dyes, you will get a blue colored article you will get. Okay, each one have its own function. Okay, ingredients. Okay, first one is resins we will take. Okay, either thermoplastic resin or thermosetting resin. So next, students, we are going to use plasticizers. We will add plasticizers. So plasticizers are the chemicals that are added to resin to increase the plasticity and flexibility. Okay, to increase plasticity and flexibility, we are going to use plasticizers. For example, tricrysyl phosphate. Tricrysyl phosphate, I gave example here. Tricrysyl phosphate, or we can use tributyl phosphate, or triphenyl phosphate, So we can use tricrysyl phosphate, tributyl phosphate, triphenyl phosphate. Okay, no? So these plasticizers we are adding into resin. So what these plasticizers will do, what is its function, we have to know. So the plasticizer molecules, they will get inside the polymer chains. You see here, I gave picture. They will get inside the polymer chain. So these are polymer chains. These are polymer chains. So they will get inside the polymer chains, okay, na? And neutralize the intermolecular forces of attraction between macromolecular polymer chains. Okay, so they will neutralize the intermolecular forces of attraction. Okay, there will be attraction between molecules, between polymer chains. So that will neutralize here, neutralized by the plasticizers. What we are using, you can see here. So they are going on staying between the polymer chains. Okay, so they will neutralize the intermolecular force of attraction between macromolecular polymer chains. So the breaking of intermolecular forces between polymer chain. So breaking of intermolecular chain will be taking place. There won't be attraction when these molecules are they are occupying the space between the two polymer chains. So definitely force will be decreased between the molecules, between the macromolecular polymer chains, so that there can be here free movement of polymer chain is taking place. Okay, so the breaking of intermolecular forces between polymer chains facilitates easy movement or greater freedom of movement of polymer chains. So that increasing the flexibility of the plastic. Increasing the flexibility of the plastic means nothing but the polymer chains, it becomes very means easy movement of the polymer chain will be there, and we can go for we can easily make into any other molded article. We can get a desired product. Okay, so to increase the flexibility of plastic, so by adding plasticizers, okay, we can go for molding into any article. But one small disadvantage, it reduces the strength, not completely. Some decrease in strength will be taking place. Okay, and chemical resistance of plastic. But we will use plasticizers to increase the plasticity and flexibility. We will use. Okay, na? Example: tricrysyl phosphate, tributyl phosphate, triphenyl phosphate. These chemicals you write. Okay. Hello, students. Hello.
Yes, ma'am.
Why we are using plasticizers? Like this chemical we are adding in resin. Tricrysyl.
To increase the plasticity, ma'am.
To increase the plasticity and
flexibility.
So there is a free movement of molecule will be taking place, polymer chains, so that we can mold into any shape. Okay. For example, you want to make a raincoat. So to polyvinyl chloride, okay, what you will add? Here plasticizer you will add. Okay, some chemical you will add so that you can increase the flexibility and plasticity, and you can go for making into shape. Okay, making into article. So that is about plasticizers. So next is fillers. So fillers, what is the functioning of fillers? Okay, why we have to add fillers in the compounding of plastics. Means two polymer resin, we are going to, first we have taken a plasticizer. After that, we are adding fillers. Okay, the other chemicals we are using. What are the other chemicals or what are the fillers we are taking is, here first we will see function. So fillers are the materials added to the molding mixture. We are preparing a mixture, okay, molding mixture, in order to give better hardness. Okay, to improve the hardness of the material, polymer resin, we will add fillers to give better hardness, to increase the strength of the resin, strength, opacity, okay. Opacity means like not transparent, okay, opacity, and good finishing product, workability to the plastics, okay. So we will add fillers. So fillers are the materials added to the molding mixture in order to give better hardness, better strength, and good finishing product. And these fillers also, it will reduce the cost of the polymers. Why means you can add the fillers percentage of up to 50% we can add, because we'll get a good strength. We can use 50% to the total molding mixture. So everywhere we won't take 50%, but we can take up to 50, 30, 40, like 50% to the total molded mixture. So, and also it will reduce the brittleness of the polymer. So it will reduce the brittleness means it won't break easily, because we are getting a strength of the material will be increasing. No? So it will reduce the brittleness of the polymer. Okay. So for example, I have given 3 here. See, some special properties are properties of fillers. First one is carborundum. This is carborundum, silica carbide. Okay. And quartz. So we will take silica oxide, silicon dioxide. So we will add a carborundum, that is silica carbide, and quartz, that is silicon dioxide, to provide extra hardness. To get a hardness, we will take silica carbide, and we will add barium salts, okay, that are added to make the plastic impervious to X-rays. Okay, when we take barium salt, when we are adding this polymer resin, okay, so what is its function means barium salt, it does not allow the X-rays to pass. Okay, it will be impervious to X-rays. Okay, students, okay, we will add barium salt also. And we will take asbestos also, because it provides heat and corrosion resistance. Okay, it provides heat and corrosion resistance. It is resistant to heat and corrosion resistance. So we will add asbestos also. So these are the fillers. Okay, so first one, to improve the hardness, barium salt we will add. Okay, impervious to X-rays. Third one, asbestos we are adding to, it will be resistant to heat and corrosion. And next, I have given some other examples, wood flour, okay, gypsum, calcium sulfate, marble flour, cotton fibers. These are also fillers, examples of fillers. Students, next class will continue slowly. Okay, na? Shall I end the class?
Yes, ma'am.
Okay.
Leave the class, ma'am.
Yes.